Welcome all. So today we will see a numerical on the shear design of the beam. Previously we have seen the concepts, the steps how to do a numerical. So today we will see the numerical. See what are the given. It is a rectangular beam of size 300 into 550 mm. Overall depth is supported over a similarly supported beam of span 6.5 meter and is subjected to a live load of 45 kilonewton per meter. If the reinforcement provided for tension is 6 number 25 mm dia and for compression is 4 number 20 mm dia, design the beam for shear by LSM and WSM both. We will use the LSM only and given M20 concrete and Fe415. So first we have to calculate the load. See here the live load is given. Here the live load is given. So the live load is 45 kilonewton per meter. So we have to calculate the self weight. Okay. So self weight of the beam, self weight is equal to 0.3 300 mm. We will convert it into meter into 0.55 into the unit weight of RCC is 25 into 1. Okay. So if we calculate this one, it will come to 4.125 kilonewton meter. Okay. So the total weight is equal to 45 plus 4.125. So it is coming to 49.125 kilonewton meter. Okay. So now we will this is the load. So we know that for similarly supported beam the maximum shear force is shear force is equal to WL by 2. So here W is 49.125 into L is, see here, 6.5. So L is 6.5 divided by 2. It is coming to 159.66 kilonewton. So it is the shear force. Okay. Now we will calculate the nominal shear stress. Okay. Now we will calculate the nominal shear stress. So let's see. See, this is the load. We know we have to calculate for nominal shear stress. We have to calculate the VU. VU is the factored shear force. So we will multiply 1.5 into this 159.66. It is coming to 239.49 kilonewton. Okay. So now we will calculate the nominal shear stress of concrete. Nominal shear stress. Okay. It's tau VU is equal to VU by BD. So here it is coming to 239.49. For kilonewton we will convert it into newton into the power 3 divided by B is 300 and small d we have to subtract 50 from that. So small d is 500. Okay. So it is coming to 1.596 Newton per mm square. So this is tau VU. Okay. So this is the nominal shear stress. Now we have to check the tau C. Okay. Tau C max. This is the maximum shear force. So it depends on the grade of the concrete. The grade of concrete see here, the grade of concrete is given as M20. M20. Okay, so let's see the chart. See here the tau c, maximum shear force tau c for M20 is 2.8. Okay, so it is tau c max is equal to 2.8 Newton per mm square. So we can conclude that tau c max is greater than tau vu, nominal shear stress. So there is no compression, diagonal compression failure. So there is no diagonal compression failure. Okay, now we will calculate the tau c. Okay, now we will calculate the tau c from table 19. Table 19. What are the requirement? The percentage of steel is required and the grade of concrete is required. Okay. Okay. So the percentage of steel we will calculate. See, the percentage of steel is AST. First we calculate the percentage of steel. Okay, AST. Then we will calculate the percentage of steel. So see, in the tension side, what is the AST? AST is the area of steel in tension side. So 6 number of bar is given. If you check here once, so see, for tension 6 number of bar with 25 mm dia. So 6 bar pi by 4 d square, 25 square. Okay, so it is coming to, okay, we are doing it total only. Percentage of steel is 100 into AST divided by BD. Okay, so we are doing it as a total. See, 100 into this one divided by 300 into 500. Okay, so percentage PT we are calculating it. So it is coming to 1.96%. Okay, so percentage PT is equal to 1.96 and M20. So we will check it here in table 19. Okay, table 19. We have got percentage of steel 1.96 and M20. See, M20 and 1.96. So 1.96 will lie in between these two value, and M20 will lie between these two value, and M20, for M20 these two value. Okay, so we have to do the interpolation. So we will do the interpolation. Let's see. Wait, I have to write the values. It is coming to 1.752 and 0.75, 0.79. Okay. So here what we will write? Here we will write the percentage of steel and we will write the tau c value here. Let's see. For percentage of steel for 1.75 value, we are getting 0.75. We have to find out for 1.96, and for 2.00 we are getting a value of 0.79. Okay, you have to find this value. So if we do interpolation, we will see 0.75 plus 0.79 minus 0.75 divided by 2 minus 1.75 into 1.96 minus 1.75. Give a minute, I will calculate the value. Bracket 0.79 minus 2 minus 1.75 into bracket 1.96 minus 1.75 bracket 0.75 plus answer. Okay, so the value is coming to 0.783. Okay, so this is the value of tau c. So this is the value of tau c. Okay, so one we have to check one thing, that is we will see the nominal shear stress value. The nominal shear stress value is coming to 1.596. The tau VU is coming to 1.596. Okay, 1.596. So tau VU is greater than tau C. So here the condition is, hence diagonal tension failure is occurring. Tension failure will occur. Okay, so now we have to design for the shear reinforcement. Okay, so you can write it here also like this. In this case we have to design shear reinforcement in form of stirrup. Okay, so first we will calculate the minimum shear reinforcement. So first we will calculate minimum shear reinforcement. Okay, so the formula for calculating minimum shear reinforcement is ASV divided by B into SV is equal to 0.4 by 0.87 Fy. Okay, so see here, if nothing is given, we consider that the stirrup is 2-leg 8 dia bar. Okay, so the ASV is calculated as 2 into pi by 4 into 8 square, so it is coming to 100.5 square. Okay, so the ASV, if nothing is given, you can remember it, we have to take 100.5 square. Okay, so we will calculate it here. 100.5 divided by B is 300. B is 300 into SV, the spacing. Mainly in shear reinforcement we have to calculate the spacing only. Okay, so we will calculate the SV and 0.87. Fy is 415. So SV is coming to 'If we calculate this thing, let's SV is equal to 100.5 into 0.87 into 415 divided by 300 into 0.4. Okay, so 100.5 into 0.87 into 415 divided by 300 into 0.4 is coming to 302.37 mm. But as per the IS code, we know 300 mm is the maximum spacing we can provide. Maximum spacing we can provide. Okay, as per IS 456. So now we will calculate the vertical stirrup. Okay, we will calculate the vertical stirrup. Now what is the vertical stirrup? The vertical stirrup can be calculated by the formula VUS is equal to 0.87 Fy ASV into D divided by SV. Okay, so this is the formula where VUS is equal to VU minus tau CBD. Okay, so VU, we know that VU is, see, first only we have calculated VU. VU is 239.49. So 23 is equal to 239.49 minus tau C. Tau C we have calculated here. Tau C is 0.783. Tau C is 0.783 into B is 300 and D is 500. So we will calculate it here. 0.783 into 300 into 500, 239.49 minus answer. So we will calculate it with 0.783 into 300 into 500. sorry. So wait 1 minute. See here, it was kilonewton. Okay, so VU here is kilonewton. So we have to, so what we will do, we will just into 10 to the power 3. Okay, so this value is in Newton, this value is in Newton, so we have also to put this value in Newton. So it is coming to 117450 minus 239.49 into 10 to the power 3. If you calculate it, the value will come to 120.99 kilonewton. Okay, we have converted it again into kilonewton. So if we put the value in this formula 0.87, we will just transfer these two values. Okay, so SV we are calculating it into 415 into ASV. See, ASV is 100.5. Okay, into D is 500 and this value is 120.99 into 10 to the power 3. So if you cancel up this value, it will come to 150 mm center to center. So how we will provide it? Okay, so how we will provide? So we will provide this value. Again, we know there are two. There is a IS provision. IS 456 tells that we have to provide 0.75D or 300 mm. So if you calculate 0.75 into 300, it comes to 375 mm. Okay, center to center. So or 300 mm. So we will provide 300 mm. Okay. So how we will provide? So if we draw a beam and these are the column, in this area the reinforcement and the shear reinforcement, and in this area there will be shear reinforcement. So in this the spacing will be 300 mm center to center, and in this area it will be 150 mm center to center. Okay, here also 150 mm center to center. So we are ending up the lecture here. Thank you.